Rings. Jovian rings. All the Jovian planets have rings. Saturn, of course, is most famous for them because it has the biggest, most beautiful, amazing ring system. But all the Jovian planets have rings. Why? Why do they have rings? Why doesn't the Earth have rings? Why doesn't Venus or Mars have rings? Well, okay, when we start looking at this, when we look at a planet like Saturn, we consider these tidal forces. Okay, tidal forces are the side effect of gravity. Gravity gets weaker with distance. So if you have a big object, then gravity pulls stronger on one side and weaker on the other, and that tends to send the different parts of it into two different directions, and it will tend to pull things apart. So if I have an object here really gosh darn close to Saturn, then the difference in the force of gravity on the near side of it and the far side of it, that difference in the force of gravity can, well, okay, if you subtract those two forces, basically what you've calculated there is the force pulling that object apart. And that can be larger than any force of gravity gathering it together. And this was, so the mathematics of this were worked out by a mathematician and astronomer and scientist named Roche. And so we calculate the Roche limit. Basically, it goes out to about 2.5 times the planet's radius. So, there's one planet's radius, distance from the center to the edge, and then about another 2.5 of those. Within the Roche limit, tidal forces would be stronger than any gravity forces causing things to pull together, to accrete together. Tidal forces... So within the Roche limit, tidal forces too strong to gather material together to make like a moon. Once you're beyond the Roche limit, now the gravity between different chunks of ice or rock or whatever you have floating around out there, now the gravity between the chunks will be larger than Saturn's gravity, this tidal force, effect pulling them apart. And so that's what we see. Near the Jovian planets, we see relatively few moons, or very small moons at that. Far from that, beyond the Roche limit, now there's where you get your nice big moons and other moons forming, but within the Roche limit, that's where you form rings. Saturn's rings are particularly interesting when you calculate, all these chunks of ice orbiting around there, and you calculate these chunks of ice got to hit against each other every few hours, really. There's so many of them. Saturn's rings are made of, billions and billions of tiny chunks of ice orbiting, or each one orbiting around together, and these flat disks, enormous structures. Billions of chunks of ice, and there's so many of them, they have to kind of crash into each other every few hours. Good grief, if they were crashing into each other every few hours for 4.5 billion years, they would have been reduced to dust. So there must be processes, either there must be some sort of process regenerating them, so maybe somehow new fresh ice is being added by volcanic activity from moons or something, some sort of process, chipping bits off of moons, something to add them. Or the other conclusion is, well, maybe Saturn's rings are young. Maybe Saturn's rings haven't been around there. Maybe if you went back 1 billion years ago, Saturn didn't have rings. Maybe there was a moon or a comet that got too close to Saturn, and then Saturn's tidal forces, side effect of its gravity, got within the Roche limit, got torn apart, and then it leaves it with this big structure of rings, and then the rings don't last forever. We don't really know. That's kind of an open question. Different researchers are kicking around different ideas. Then you look at the rings of Jupiter and Uranus and Neptune, and their rings are much more limited, much darker, much, sootier, rubblier sort of material. And it's, okay, this could have existed for a longer period of time. So that gives us a little bit of an understanding of how and why the Jovian planets have rings.